Hello viewers, in today's class we are going to discuss an important application of derivatives, right? So here we are going to discuss a problem from increasing and decreasing functions, right? So here we'll solve this problem, that is, find the intervals in which this function, that is f of x is equal to x over x square plus 1, is increasing and decreasing, right? So here we are given a function and we have to tell with the help of derivatives the intervals in which this function is increasing and decreasing, right? So before getting into this problem, let us quickly revise the definition of increasing functions and decreasing functions. So here we'll simply use the definition that if we have a function, say y is equal to f of x, right, and suppose its domain D is defined, and this function f of x is said to be increasing if we have f prime of x is greater than 0 for all x belonging to this domain D, right? So when the derivative of a function is positive, right, if the derivative is greater than 0 for all x belonging to the domain of the function, then the function is said to be increasing, right? And when the derivative is negative or it is less than 0 for all x belonging to the domain, then we say that the function is a decreasing function, right? So this is the definition which we are going to use here to find out the intervals. So viewers, here I would like to mention that see, when we are taking the function as increasing, we are taking this inequality, that is f prime of x is greater than 0, right? So when we take this condition, then we say that the function is strictly increasing, right? But when we take f prime of x is greater than or equal to 0, then we simply say that the function is increasing, right? And similarly, when we take decreasing function, then the condition is f prime of x is less than 0, right? So the derivative is less than 0. So when we here do not take the equality sign, then we say that the function is strictly decreasing, right? But when we take this condition, that is f prime of x is less than or equal to 0, then we simply say that the function is decreasing, right? So the condition for increasing and decreasing function is almost same here, with the difference that when we take the condition for strictly increasing function, then we do not take the equality sign here, right? So this is for strictly increasing. Similarly, for strictly decreasing, here we do not take the equality sign, right? But when we simply say that the function is increasing, we take the equality sign, and similarly here we take the equality sign, right? And moreover, we know that at the turning point, see, whenever a graph goes like this, or if it rise like this, then the turning point, or at the turning point, the function, the derivative of the function is 0, right? Similarly here we have f prime of x is 0, right? So this equality sign, in fact, it reflects that at the turning point, the tangent to the curve at that point is parallel to the x-axis, right? Or the derivative is 0 when we have this equality sign, right? So now let us first find out the derivative of f of x, right? So here we see that f of x is a rational function because it has numerator and denominator both are polynomial functions, right? So in order to find out the derivative of f of x, we have to make use of the quotient rule for finding out the derivative, right? So we can now write d by dx of x over x square plus 1, and here we'll make use of this result, that is, if we have two functions u and v of x, then the derivative of u over v is given by v, then we have du over dx minus u dv over dx divided by the square of the function v, right? So this is the well-known result, and here u is x and v is x square plus 1, right? So f prime of x is now equal to we have x square plus 1, the derivative of here we have x, because u is x, then we have here x, and then the derivative of x square plus 1, and in the denominator we have x square plus 1 whole square, right? So now we can further write this expression as x square plus 1, the derivative of x is 1, then we have here x, and the derivative of x square plus 1 is 2x, and here we have x square plus 1 whole square, and this is x square plus 1 minus 2x square, and we have x square plus 1 whole square, and x square minus 2x square is minus x square, so we have 1 minus x square over x square plus 1 whole square, right? So this is the derivative of this function f of x, right? Okay, so now we know that derivative is an important quantity which tells a lot about the nature of the function, right? So now we'll utilize this expression to further investigate this function regarding the intervals in which this function is increasing or decreasing. So viewers, now let us first take the case of increasing function, right? So here we have already calculated the derivative, and for increasing function we know this condition, that is the derivative must be greater than 0, right? So f prime of x is here 1 minus x square over x square plus 1 whole square, and here this is greater than 0, right? So now here we have an inequality, and we have to solve this inequality, right? So here if we observe this side, that is the left hand side of this inequality, we see that in the denominator we have x square plus 1 whole square, right? And this quantity is always greater than 0 whatever be the value of x, right? Because this is a square quantity, and whatever be the value of x, the value of this quantity as a whole is always greater than 0, right? So in order to this inequality to be true, the numerator, that is 1 minus x square, must be greater than 0, right? Because we have already seen that x square plus 1 whole square is always greater than 0, right? So in order to this side to be greater than 0, now this numerator has to be greater than 0, right? So now we have to solve this inequality for x, right? So now we can write this inequality as minus x square greater than minus 1. We can take this 1 to the right hand side, and now if we multiply both sides with the negative sign, then the direction of this inequality get reversed, right? So now we have x square is less than 1, right? Okay, so now we can write this inequality as x square less than 1 square, right? And now here we'll make use of a direct result from inequalities. So now from the theory of inequalities, we know that if we have x square less than say a square, right, where a is some real number, right. So whenever we have an inequality of this type, then the value of x always lies between minus a and a, right. So here we have this result. And see, here we have x square less than 1 square. So the value of a, if we compare these two, then the value of a is 1, right. So if we apply this result to this one, then the value of x must lie between minus 1 and 1, right. So this function, that is f of x is equal to x over x square plus 1, is increasing for all x which lies between minus 1 and 1, right. So this is the interval in which this function is increasing, right. So we can also write this expression, this inequality as x belongs to this interval, that is minus 1 to 1, right. So here this is the interval in which this function is increasing, right. So here I would like to mention one more important thing, that is, see here in the definition of increasing and decreasing function, we have taken the inequality that is either greater than or less than, right. So here we have not taken the equality sign, right. See, if the derivative of a function is greater than or equal to 0, then we simply say that the function is increasing, right. And if the derivative is less than or equal to 0, then we simply say that the function is decreasing, right. But when we omit this equality sign, right, when we do not write this inequality sign, that is, say if we simply write f prime of x is greater than 0 or f prime of x is less than 0, as we have written over here, right. So in that case we say that the function is strictly increasing or strictly decreasing, right. So in this case, when we take f prime of x is greater than 0, the function is strictly increasing, and when f prime of x is less than 0, then the function is strictly decreasing, right. So when x lies between minus 1 and 1, this function is strictly increasing, right. So now let us find out the interval in which this function is strictly decreasing. So now for the strictly decreasing function, we have this condition, right. That is, f prime of x is less than 0 and f prime of x is equal to 1 minus x square over x square plus 1 whole square, and this is less than 0, right. So as we have explained, in case of strictly increasing function, this quantity, that is x square plus 1 whole square, is always greater than 0, right. So this quantity is positive, right. So it means for 1 minus x square over x square plus 1 whole square to be less than 0, and this quantity, that is 1 minus x square, has to be less than 0, right, because this is the positive quantity, the denominator is positive, being a square quantity, right. So the denominator is positive, so this quantity, that is 1 minus x square, has to be negative, right. So if we now solve this inequality, we can take this 1 to this side, and now if we multiply both sides with the negative 1, we'll get x here positive, but the direction of the inequality get reversed. So here we have x square greater than 1, right. So this function f of x is strictly decreasing when x square is greater than 1, right. So now we have this inequality, that is x square is greater than 1 square, right. So now see, when we have x square less than 1 square, we have this inequality, right? But here we have x square greater than 1 square, right? So for this type of inequalities, we have one more result of this type, right? And the result, it goes like this. If we have x square is greater than, say, a square, where a is some real number, then x belongs to this interval, that is from minus infinity to a union. Then here we have here we can write minus a, and here we have a to infinity, right? So whenever we have x square greater than a square, x belongs to this interval. So here again the value of a is 1. So now this function f of x is strictly decreasing when x square is greater than 1 square. So we can find out the interval by using this inequality. So x belongs to this interval, that is minus infinity to minus a is 1. So here we have minus 1, then we have union, and then we have a to infinity, that is 1 to infinity, right? So this is how we can find out the intervals in which this function f of x is strictly increasing or strictly decreasing, right? And the only difference between increasing and strictly increasing is that when we do not take the equality sign here, then we say that the function is strictly increasing, and when we take, or when we incorporate the equality sign here, then we say that the function is simply increasing. And likewise we can say that f of x is strictly decreasing when f prime of x is less than 0, and when we incorporate this equality sign here, then we say that the function is simply decreasing, right? So viewers, by using this inequality and this one, we can easily solve this type of problems.